By 2020, AT&T plans to move about 80% of its network to be virtualized. In order to do that, we need about more or less 1,000 OpenStack sites. And obviously, managing 1,000 OpenStack sites comes with quite a lot or few new challenges that happened and we've seen. So my name is Shimon, and with me is Mark, and we're here today to discuss two challenges that we've seen and the solutions we've developed here in Tel Aviv to these challenges. So first, a few words about AT&T, kind of large company, about 160 billion revenues in 2016. Our network currently is about 125 petabytes per day, and by 2020, because of big data and because of, I don't know, Internet of Things and everything, we reckon it will be about 10 times that amount. So we kind of need a big network. In Israel, AT&T has about almost 300,000 employees, another 300,000 constructors, but in Israel we have a small site, about 600 people, employees. We're growing. We've, I think in 2016, 100 new employees joined our company. And we work on many, many projects for AT&T, but we're here to discuss our part in the network. So I'll start by discussing AT&T's approach to OpenStack scaling. We'll discuss managing resources across multiple OpenStacks, and Mark will discuss capacity management problem that we have. So AT&T's cloud, we call it the AIC, AT&T Integrated Cloud. When we started working on it, it had two areas. So the first area is a site. Okay, we call it an LCP, local control plane, and on the LCP we have the main controller parts of OpenStack, Nova, Cinder, Glance, Heat. Besides that, we have many LCPs, and we have something we call the distributed control plane. On the distributed control plane, we have Keystone, okay, which manages all the permissions and everything, and we have the Horizon dashboard, and then we have the message queue. Now, it's easy to manage because we have a single key. All you need is a magic F. Okay, so the problem with having a DCP is it's kind of convenient to have a single keystone and a single Horizon dashboard for all their OpenStacks, but we have a problem with, let's say the DCP is installed in Dallas and we have a site installed in Atlanta, maybe here in Haifa soon, and it's caused a lot of network traffic, okay? Every single access needs to go to Keystone and back, so we're going from Atlanta to Dallas to Atlanta to Dallas, so this obviously causes also latency problems. Obviously, we have, I wouldn't call it a single point of failure because we have high availability on the DCP, but still, if we want to upgrade the DCP, it's not so easy. So what we came up with AT&T is an architecture we call Share-Nothing. It means every OpenStack, every site stands by itself. Okay, we have a single site. It can't access any other OpenStack sites. And that way, if you want to upgrade, there's no latency problems. Everything is easy. Everything is simple to work. Except now we have to manage 1,000 different OpenStacks. So AT&T, for example, gives out an Ubuntu version every 6 months or something like that with all its security issues. And now how are we going to deliver this Ubuntu image to 1,000 OpenStack sites? So moving on. So moving to 1,000 OpenStack sites causes us an operational challenge. How are we going to push all kinds of shared OpenStack resources from a single OpenStack environment to multiple OpenStack environments? In order to do that, we developed a component we call ORM, OpenStack Resource Management. ORM is a lightweight collection of microservices that accepts requests from certain clients, and once we get this request, in order to process the request according to the resource type and send it to something we call an ORD, which sits on the OpenStack side. The ORD receives the heap template, sends the heap template to heap, and then it will create the relevant resource, let's say an image, on the relevant OpenStack. So If I look under the hood, okay, so it looks something like this. We have a client, many clients, we'll discuss them in a second. It sends a request to ORM. ORM takes the request, transfers it into a heat template, and then it can send it to any one of the OpenStack sites to the ORD agent, which then sends it to heat, and we can thus create the resource. So, like I said, it's ORM is a bunch of microservices. So we have a microservice per each resource. For example, if you want to manage flavors or images or our customers, we also have a microservice called a region management service to manage all our OpenStacks themselves. The RDS is a microservice that receives, actually manages all the other microservices. It receives the request from one service, and at the end of the day, sends it out, the heat template, to the ORD agent, which sits, like I said before, on the OpenStack itself. So we developed ORM as a classic OpenStack project. We started from a cookie cutter project. We worked with Talks and with Tempest, and we're hoping that AT&T apps releases ORM, I don't know if in 2017, to the community. It's something useful for many people working with multiple OpenStacks, so at least the way we see it. We had to develop our own GUI for this from certain internal reasons, also because we didn't like working with the Horizon. A lot of systems in AT&T are using our APIs from their own systems in order to bring resources to AT&T's OpenStacks. So Mark will come now to discuss capacity management, and if you have questions about ORM or AT&T Cloud, I'll be here after Mark. So in a single request, you can send, okay, let's say you have an image, okay, a new image, Ubuntu image, and you want to send it to, I don't know, a list of your OpenStack sites. You just send a single API request saying which OpenStacks you'd like to upload an image to, and ORM will automatically deploy the image in whatever OpenStack you decide.
Okay, so now let's look at the problem of the capacity management when you have 1,000 independent instances of the OpenStack. And first of all, let's look a little bit at the problem of the capacity management in the cloud, in the infrastructure as a service environment. We have here a lot of resources. We have a lot of users that take resources, release resources. And we always have some amount of resources that kept free, that the users will be able to allocate them. And this actually creates the illusion of infinite capacity. But of course, it's illusion only for the users of the OpenStack, but not for the cloud service provider. Cloud service provider actually should work very hard in order to make this illusion, to keep this illusion. And we have people that call capacity planners that actually take care for this. And when some tenant actually want to, what the tools that we have today in the OpenStack to manage it? We have actually quota. This is the only thing almost that we have in OpenStack for this purpose. So we can limit the amount of resources each tenant can allocate. And if we take the amount of all the quotas in the OpenStack and compare it to the physical capacity, we can keep some ratio. We can also look at how many resources are used in order to decide if we want to approve more over-allocation or less over-allocation. But these are the tools that actually capacity planners have. And they can approve the request and can reject the request. They can postpone the request, or they can decide to build more hardware and increase the capacity on the site. And they need some means to do all this work. They need the information, they need the way to compare it, they need to analyze it. And as much information as they have, the better they can do the work. And in private cloud, unlike probably the public cloud, we do have ability to imply some policies and some processes on the users that know more about their future plans. They know how much resources they will need in future. And if they provide this information, then we'll be able to manage the information better. But to do all this, we need some capacity management tool, capacity reservation tool, capacity planning tool, whatever you call it, but you need some tool to manage all this that actually will collect all the information, present it in some usable way, and also will integrate with your business logic of for capacity request, and or provide its own logic for the flow of the capacity. So what is actually the flow of the capacity? So first of all, in this presentation, first of all, I'm talking about the computing resources and storage resources. For networking, probably the story is a little bit different, but we don't have time for it. So first of all, we have deployed capacity. Deployed is it's the green one in this picture. Then we already know about some future deployment plans. It's a yellow one. And this comes with a date. We know when we plan, at least we plan to deploy some additional resources. And then we allocate quota for tenants. We over-allocate quota for tenants. And this quota comes from the deployed capacity. And then users can, actually, the black one is what the user actually taken. That, of course, less than the allocated one. Now, there is a good question. When you have the capacity request, when can you allocate quota for the capacity request if you take into account the future deployment? Can you do it right now? Probably no, because if you provide the quota right now, the user can use it immediately and over-allocate or overuse the cloud. On the other hand, it will going to happen sometimes in future. So you need to wait to manage it. And the way to manage it is actually create the process of the resource reservation. So first of all, users come and they post the request. We need more capacity on this specific date. By the way, it can be also with the end date. And then at this point, capacity planners can come and look at the request and see, okay, do we have enough resources for it? If we have, everything is fine. If not, again, we can delay the request. We can move it to another instance of the OpenStack, or we can decide to build more capacity. Once we approve the request, we actually create the reservation. It's already approved one, but it's still not quota. Why? Because it depends on the planning, or the capacity plan to be deployed. And when the dates come, we need to check this again. Why? Because we planned it to be ready on specific date, but we know that things happen. We can come to this specific date, and some things were delayed, the hardware was not deployed, or probably just some very important customer came and asked for an urgent allocation, and now we don't have it. And so again, now we need to make some decision, like playing with and moving the request probably to other instance. And only then, if everything is fine, we actually can move part of this reservation to the quota. So to do all this work, what information we need? So we said we need the current deployment status, how much hardware we have now. We need to know the future deployment plans. We need to know how much quota we already allocated. We need to know what is the actual use, again, because it will help us to make the decision about the over-allocation. We need to know how much reservation we'll already have, and it will be very helpful if we know also the future plans, like for the long term, for next year. Then we can prepare with the plan of the new deployment and new OpenStack instances for the next year. And where we can take this all information. Of course, the first source is OpenStack itself. What we can get from there? Of course, we can get from there the currently allocated quota. We can get from there the actual use. We can get from there the currently deployed capacity up to some extent. Why up to some extent? Because OpenStack only knows about the hardware that are provisioned in OpenStack. Just let's take an example, for example, Cinder, block storage. If Cinder knows how many storage mapped to the snapshots. But if there are some, not all the hard drives are mapped to the snapshots, you don't know that you have it. How do you know that you indeed have it deployed? you need probably some other system. And now we are coming to the enterprise systems, not to the OpenStack system that provide additional sources of information for us. Here you can keep actual hardware inventory, because probably you do have some systems that help you to plan and build new sites. And here is your inventory. You have some system to manage reservation. You have some system to manage the future demand. And all this will be helpful. So now you have the information. Just the last thing, you need to build the tool. So what alternatives to do it? First of all, of course, some commercially available systems exist. And you can consider to use them if they are good for us. Then, or maybe first of all, you should look for the open source solution. And here we also have some candidates. There is some project in OpenStack called Blazor. Probably not many people heard about it. Who heard about it? Can you raise a hand? Yeah, it's a situation, nobody. So we'll talk about it in a couple of words, but project exists. OpenNFV consortium also has a project called Promise. That target is to address the capacity, and of course you can always build your own. But now let's look what we have. So if you're going to commercially available systems, then first of all you have very nice GUI usually in this case. You have integrations with many clouds, with OpenStack as well. The problem here will be the business logic that assumes and the ability to customize it. If you can use it for your purposes, you are fine. If you cannot, it will be more difficult. And again, our case, thousands of independent OpenStack that we didn't find the available solution for it. OpenStack Blazor project. OpenStack Blazor project was actually dormant for a long time and was revived recently. And it introduced the concept of leasing the resource. Actually marking the resource, whatever virtual resource or hardware resource, for example, even bare metal resource, as leased from specific date to specific date. But then actually this solution looks more like your agent in the OpenStack for the overall capacity management system. And again, you didn't hear about this project, so it's not very mature state. Then there is OpenNFV, Open Platform for NFV Consortium, one of the Linux Foundation projects that was mentioned here today already. And it has a project called Promise. And Promise actually provides the integration between Blazor in OpenStack on one hand and NFV orchestrator of the OpenNFV. Again, not very mature project, but it already provides some mean of taking things to a larger database out of the OpenStack, but still it assumes the single OpenStack instance. Build your own. Of course, you can address your needs the best way, but time, resources, money, not open source. You cannot gain from the contribution of other teams. However, you can do the opposite. You can contribute it to the open source when it is ready. And this is actually the thing that we are looking for. So comparing between all alternatives, and this table, of course, it's simplified. It's a much more complex solution decision, just highlights of our situation. We had very strong requirement to have very good graphical user interface to make the capacity planners available to analyze the resource a good way. We had, of course, very strong requirement supporting multiple OpenStack instances. We have business specific that we are hard to integrate into existing commercial solutions. And existing OpenStack and OpenNFV solutions were not supporting multiple OpenStack instances as well. So we finished with probably initially which looked like a less favorable approach, going with to build your own system. But again, we eventually AT&T can consider to make this solution available to the open source and to other companies that face similar challenges. Any questions? So of course, once we have the system built and we have the database in the system and we have also the historical data of the data system, then we are able to generate the historical graphs of the capacity and indeed look at the trends. It's one point of view. Another point of view, we look again. We look at the how much we have deployed, how much is allocated, and how much is used. And actually, these are the three main parameters that, and we know how much is planned to be used in the near future. So from this parameter, we actually can decide if we, for example, move the next reservation to another instance, or we decide to, in long term, we decide to increase the capacity in specific instances. Thank you.